Hey guys, welcome to day 3. Today you're going to learn all about conditional statements, if, else, elif, logical operators, code blocks, scope, global and local namespacing, and a whole lot more. And by the end of the day, you will know enough to be able to build this awesome choose your own adventure game. So this is what it looks like when it loads. And our mission is to find the treasure. So it tells us you're at a crossroad. Where do you want to go? Left or right? Let's say I want to go left. You come to a lake. There's an island in the middle of the lake. Type wait to wait for a boat. Type swim to swim across. I'm going to wait for a boat. You arrive at the island unharmed. There's a house with 3 doors. 1 red, 1 yellow, and 1 blue. Which color do you choose? Let's choose red. And unfortunately, it's a room full of fire. Game over. So this game lets the user make decisions, and depending on what they've chosen, it continues the game storyline. If you want to have a go at this game, you can head over to treasure-island-end.appbury.repl.run and have a play around with the game. And once you're ready, head over to the next lesson, and we're going to start picking up the skills that's going to be required in order to build this game. So I'll see you on the next lesson. Here's a question. Have you ever sat in your bath and wondered, why is it that no matter how forgetful I am, my bath never overflows like this? This is something I was thinking about the other day. And I realized that it's not because I'm particularly diligent. I forget stuff all the time. I mean, pizza, anyone? It's what my pizzas usually look like. But the reason why our bathtub or the sink doesn't overflow is because of this fantastic piece of engineering, the overflow. So this means that whenever the water reaches beyond a certain level, about here, the water starts overflowing so that the bathtub doesn't overflow and annoy your neighbors downstairs. In fact, we could represent this mechanism with a conditional statement. When the water level is, say, greater than 80 centimeters, then it should drain the water, but if the water level is not greater than 80 centimeters, it should continue filling up the tub. This type of conditional statement is known as an if-else statement. Depending on a particular condition, we would do either A or B. And when we want to write Python code to represent this, it looks something like this. There's the keyword if, and then the condition that we're testing for, and then a colon. And after the colon, we've got an indented block of code, which should be executed if this condition is met, if it's true. But if it's not true, then we will skip to the else block, and it's just the else keyword with a colon. And then this code block would execute if the condition is false. So we could represent that previous bathtub situation with code that looks a bit like this. Let's say our water level is at 50 centimeters, and then we would test if the water level is greater than 80 centimeters. Well, if that is the case, then we should drain the water. But if it's not greater than 80 centimeters, in other words, else, well, in this case, we should just continue filling up the bathtub. Let's put this into practice with a real-life problem. Now, let's say that you've gotten a job at a theme park, and your first job of the day is to write some code that replaces the ticket box. Now, there's a couple of things that you'll need to think about. Firstly, in order for somebody to actually purchase a ticket to go on the roller coaster ride, they will need to be over 120 centimeters. So we have to check what their height is, because if they're too short, then we won't be able to sell them a ticket anyways. In the course resources, I've included a link to this flowchart that I've created on draw.io. This is a really, really useful tool for creating any sort of flowcharts or diagrams, and it's really easy to use. Now, if we take a look at this flowchart, this is basically the logic that we have to program using our if and else statements. If the person who's trying to purchase a ticket is not over 120 centimeters, then they can't ride on the roller coaster. But if their height is greater than 120 centimeters, then they can ride. So let's try it out. If you head over to the starting replet you'll find some starting code in there, and you can go ahead and fork this replit. All that I've got here is a print statement that says welcome to the roller coaster, as well as an input asking the user for their height in centimeters, and then converting this string into a whole number, an integer. And then I'm storing it inside this variable called height. Now we're going to check whether if the height that the user has typed in is greater than 120. So we use the keyword if, and then we check if the height is greater than 120, and then we add the colon. And now when I hit enter, you'll notice that the code editor has automatically indented me slightly over. I'm not over here, because in Python, the spacing and indentation is really, really important. It tells the computer that the code that I'm about to write is what should be executed when this condition is met. So what should happen? If your height is over 120, then we will just print, you can ride the roller coaster. But what should we print if height is not greater than 120? Well, in this case, we would use the else statement to catch when that happens. And it's really important that you don't write the else here, because this is indented over. Instead, you want it to be at the same indentation level as the if statement. These two are essentially a pair, if and else. Now, after the else keyword, we again add a colon, and then we hit enter, and we're now indented again. And here we can write the code that should happen if this condition is false. Sorry, you have to grow taller before you can write. So the really important things here are the condition, which we're testing for, is the value of height greater than 120, the syntax of this code, so the keywords if and else, as well as the colons that come after each of these lines, and finally also the indentation. Everything that is indented after the if is a block of code. So this is indented and it's effectively inside this if. So this line of code lives inside the else statement. This block of code lives inside the if statement. And if you mess up on the indentation, then you're probably going to get an indentation error telling you that this line, 5, probably should be indented. But when we do actually correct it and we hit run, let's say that our height is 130 centimeters. Then we get back, you can ride the roller coaster. But if our height was, say, 90 centimeters, then we get a different outcome. We get, sorry, you have to grow taller before you can ride. So by using if and else statements, we're able to get our code to do different things, either printing this line or printing this line, depending on a condition that we're testing for. Now, when we use this greater than sign, effectively what we're saying is that is the height greater than 120, which means that it does not include 120. In fact, if I run this code and if I type in my height as 120, then it actually goes into the else block and prints this. So if we wanted to include 120 centimeters so that all the people who are exactly 120 centimeters can ride the roller coaster, then instead of just using a greater than symbol, we have to write greater than or equals. So these two symbols have to be next to each other. And now when I run my code and I write 120, you'll see that it's now falling into this block of code and it's telling me that I can ride the roller coaster. Now these are called comparison operators, and we've already seen greater than, so lesser than is pretty self-explanatory, but we've also seen greater than or equal to and lesser than or equal to. So if you want to include a particular number or particular value, when you do these comparisons, you would be using these instead. Now in this table, there's also the equal to and not equal to. For example, if you wanted to check if somebody's height is equal to precisely 120, then you would use two equal signs. And very often it gets a little bit confusing, especially if you're new to programming, when you're typing equal signs, because sometimes we're typing 1 and other times we're typing 2. It's important to remember that when you have one equal sign, it means that you're assigning this value to this variable. But when you have two equal signs, you're checking to see if the value on the left is equal to the value on the right. And they're completely different. Now, the good thing is that when you get it wrong, usually you'll get enough clues in the error to actually hint to you, hey, maybe there's something that's wrong here, right? Because the syntax doesn't look right. For this to be a condition, it has to be something that evaluates to true or to false. And height equals 120 does not evaluate to either. So by changing it to this, we're saying if height is equal to 120, then we'll execute this line of code or any other lines which are in the same block of code. But if the height is not equal to 120, then we're going to execute this block of code. So if I write 120, then that works. But if I write 121, then it does not work. Similarly, you can also check for not equals to, which just flips it around. But in our case, it makes sense to say if the height is greater than or equals to 120, then you can ride the roller coaster, but otherwise you cannot ride the roller coaster. By using if and else statements, we can get our computer to do different things and respond differently depending on different conditions. So in the next lesson, I've got a coding exercise for you. I'll see you there. All right, guys, it's time for yet another code challenge to test and see if you've learned what was covered in previous lessons. So head over to the assignment that is day 3.1, odd or even. Have a read of the instructions and try to see if you can create a program that checks whether if a number that you input in the console is odd or even. Now, the thing to remember here, though, is that we're introducing something called the modulo, and you can create the symbol by simply typing the percentage sign. Now, what the modulo does is it will divide a number, say 7, by another number, let's say 2, and then it'll give you the remainder of that division. So 7 divided by 2. 7 split into portions of 2 is 2 plus 2 plus 2 plus 1, right? So 7 divided by 2 can be divided 3 times with a remainder of 1. And that's what the modulo gives you. So you can also type code straight into the console, like I am going to do now. 7 modulo 2 gives me 1. Now, it's the same thing if you try to divide by other numbers. Let's say 7 modulo 3, well, that is 3 plus 3 plus 1, right? So 7 modulo 3 will also give me 1. So this is a way for us to divide a number by another number and get the remainder. And you're going to be using this modulo to solve this code challenge. Have a read of the instructions, have a look at the examples, and see what it is that we're expecting to be printed in the console here. And then go ahead and write your code and see if your output matches what it is that we're expecting. So 56 should be even, so you should be printing this is an even number based on that input. Pause the video now and give this code challenge a go. All right, so I mentioned that the modulo gives us the remainder, right? So what do we know about even numbers? Well, even numbers, they're always divisible by 2. If we pick any even number, say 54, and then we do modulo 2, so 54 divided by 2, it should always give us 0 as long as that first number is even. So 68 modulo 2, again it's 0. But then when we come across an odd number, say 53 modulo 2, then this is now going to give us 1. We can use our code to check for when the result is 0, in which case it's an even number, and when the result is 1, in which case it's an odd number. if you've gotten stuck until this point, then this is a really great time to pause the video again and go back and give it another go. And then we'll go through the solution together. We can simply write an if statement to check if the number that was inputted is divisible by 2 with 0 remainder. Well, in this case, then we can pretty much be sure that this is an even number, because as we've shown, all the even numbers, when they divide by 2, there's always no remainder. So in this case, let's add a colon. We can print pretty confidently that this is a even number. Now, what about the cases where the number, when divided by 2, is not equal to 0? Well, then it's probably going to be an odd number. So in this case, we can use an else statement to catch that. And when we have an odd number, we'll simply print this is an odd number. So that's it. Just 4 lines of code using what we've learned about if, else, and also the comparison operator. Now, if you got stuck on this and you needed to watch the solution, then I recommend really going back to your code and playing around with it so that you can get the code to work. And then try and see if you can test if a particular number is cleanly divisible by 3, by 4, by 5, and then see if the final program actually works in the way that you expect it to. But once you're ready, head over to the next lesson where we're going to talk about even more complex ways of using if and else statements. So for all of that and more, I'll see you there. In previous lessons, we learned about using the if and else statements to check whether if somebody is over 120 centimeters or not, and allow them to actually purchase a ticket if they are over a certain height. Now, in addition to the height, there's another condition that we need to check for, namely their age. If somebody is over 18 years old, then they should be paying the adult price, which is, let's say, $12. But if they are 18 or under, then they should only be paying $7. So how can we represent this extra condition that we need to check for in our code? Well, we could use something called a nested if-else statement. We've seen our if-else statements look like this, where it's only got 2 choices. If this condition is true, do this, otherwise do that. But in a nested if statement, once the first condition has passed, we can check for another condition. And then we can have another if-else statement inside this if condition. In order for this thing to happen, this has to be true and this also has to be true. In order for this to happen, this condition has to be true, but this condition has to be false. So essentially, the computer first looks at the larger picture, which is this first condition, and decides on whether if it should go into the else block here, or if it should go into the nested block inside the if statement. So now this is what our flowchart looks like. In the first if statement, we check whether if their height is over 120 centimeters. If no, then the if statements all end. You can't ride, you can't buy a ticket. But if yes, we actually take them to yet another if statement where we check their age. If their age is 18 or under, then we give them a $7 ticket. If they're over 18, then they have to pay $12. So the place where we're going to nest our if statement is inside here. Notice how it's indented, so it's already inside this if block, and this already has to be true. Now here we're going to create another if and else statement, and the condition checks for their age, so we better ask them for an age. Let's say age equals, convert the input to an int, and what is your age? So now that we've gotten hold of their age, we can see if their age is less than or equal to 18, well, in this case, we're going to give them the $7 ticket. But else, namely, if this is not true, if their age is over 18, well, in that case, we're going to give them the $12 ticket. So now we have a nested if statement, because this if and else statement lives inside this if statement. So this condition will only be checked if this is already deemed to be true. Now let's say our situation got a little bit more complex. The boss comes over, checks our code and says, wait. There's actually more price tiers than that. In fact, if you're less than 12 years old, you pay $5. If you're between 12 and 18, you pay $7. And if you're over 18, then you pay the full adult price, which is $12. Now, there are 3 possibilities. So how do we represent this in our if statement? Well, we could use something called the elif. Instead of having a simple if-else statement where there's only one condition, if it's true, do this, otherwise do that, you can add as many elif conditions as you want. So we can check for condition 1. If that's true, then do A. But if that's not true, then we can continue and check for condition 2. If condition 2 is true, well then we can do B. And finally, if none of those conditions were true, we can do this final thing. Our flowchart now looks something like this. And this is the logic that we're trying to program. Once we're inside this nested if statement, we're going to check if their age is under 12, in which case they should pay $5. If they're between 12 and 18, then they should pay $7. And finally, if they're over 18, then they should pay $12. Now, the first thing I'm going to check is if the age is less than 12. Under this condition, they should pay $5. So let's change that to 5. Now, the next condition should be created using an elif, which stands for else if. So it means if this is not true, else if, can you check if this is true? Well, in that case, then we should do this. For example, if the age is not less than 12, so they're over 12, then are they under 18? Well, then this condition basically catches everybody who's between 12 and 18. And finally, if they're not less than or equal to 18 and they're not less than 12, then that's everybody else who is over 18. Now, remember that we can use as many elif conditions between the if and else as we like. So I could add another elif that checks whether if the age is less than, say, 22. Well, in this case, do something else. And then I can keep going with these elifs until I'm done with all my conditions. So have a play around with this code, write it yourself, see if it makes sense, and then mess around with the elifs so that it does what you expect it to do. And then once you're ready, go ahead and head over to the next lesson where I've got a coding challenge for you. So now that you've learned all about if, elif, and else, as well as nested if statements, then I've got 2 code challenges coming up for you. In the first one, in the code challenge that's called Day 3.2 BMI Calculator 2.0, this is going to be an upgraded version of the BMI calculator that you created yesterday. Instead of just working out the BMI value of somebody, we're going to give them an interpretation. You might have come across a BMI chart that looks like this, where it divides up people's BMI and tells them whether if they're underweight, normal weight, overweight, etc. And this depends on the value of the BMI. So if the value of the BMI is less than 18.5, then they are underweight. If they're over 18.5 but below 25, then they have a normal weight. So your job is to not only create a BMI calculator, but also to give them the corresponding interpretation message. Now, it's really, really important that you use the words here that are highlighted in bold in your interpretation, that based on a particular height and weight, you actually give them the correct interpretation. Pause the video and try to give this challenge a go. All right, so how did you get on? There was a little bit of revision from what you've done previously. Hopefully you've been able to calculate the BMI without much trouble, and then use what you learned about if, elif, and else to provide the user with the corresponding interpretation for the BMI that they have. Let's start out by calculating the BMI. And the BMI, according to this equation, is equal to the weight in kilograms divided by the height squared. So we've got the weight already, and then we divide it by the height to the power of 2. Now, notice how I've already converted these inputs to floats, so we don't have to do what we did previously when we were calculating the BMI. Now, what the exercise does mention, though, is that we should round the result to the nearest whole number. But you probably remember how to do this, right? Using the round function. So if we wrap the entire equation inside a round function, then it's going to round it to the nearest whole number. So if this is what you got stuck on, then head back to your code and just fix it. Now, once we've calculated the rounded value of BMI, the next step is to give the user an interpretation message based on their BMI. So let's start with the first one. If the BMI is less than 18.5, well then in this case, they're actually underweight, right? So we'll print something like your BMI is, and then inside here we'll insert the value of their BMI. And this of course is using F strings. So let's add an F to the beginning. Your BMI is this particular value and you are underweight. Now, what if their BMI was between 18.5 and 25? Well, because we've already checked that their BMI is less than 18.5, then if this is false, because it's jumped to the next level, then we don't actually have to check this. All we have to do is check that it's still below 25. And to do that, we're going to use an elif. So elif BMI is less than 25. Well, then in this case, we're going to print your BMI is this particular value and you have a normal weight. If this is a little bit mysterious to you, why it is that I'm not checking that their BMI is over 18.5 but below 25, and I'm simply just checking that it's less than 25, then I recommend having a play around with the code as it is right now and trying out some different values for BMI. Just change this to say 18 and then try maybe something like 22 so that it's caught by each of these conditions. And then you'll soon realize that this if, elif, else is an entire group of statements and it's going to check this one first, and only if this fails when it's false does it go and check the next one. So then this is only going to be printed when their BMI is over 18.5 but below 25. And once you're comfortable with this, then the rest of the statements should be pretty easy. Now, once we've reached here and their BMI is not less than 35, and we want to catch the remaining cases where the BMI is over 35, then all we have to do is add an else statement. That's all we have to do. We've managed to check for those people who have BMI less than 18.5. If it's not less than 18.5, well, is it less than 25? So this will print when the BMI is greater than 18.5 but less than 25. And we've done that for all of these separate statements. If you struggled with this code, then I recommend having a look back at the previous lesson where we talked more in detail in terms of if, elif, and else. If you struggled with this challenge, then have a go at pasting the code that's in the solution into the Thonny code editor. And instead of having the BMI being a worked out value, just set it to some different numbers. So for example, if we start out testing, if the BMI is equal to 18, which of these will it fall into? Then we can click on the debug, step into each of these, and you can see that when it evaluates this condition, is the BMI less than 18.5? Well, 18 is less than 18.5, so this is true. And in that case, it's going to execute this line of code. So it's going to print out your BMI is 18, you're underweight. And then it's done. That's the end of the code. Now, if we change this to say 22, however, and we click on debug, then it's going to evaluate the first condition. Is 22 less than 18.5? That's going to be false. So then it skips to the next elif that it can find, and it checks whether if the BMI 22 is less than 25. So now it's going to execute this print statement. Have a play around with that if it's still a little bit mysterious to you. And hopefully once you're done there, then you'll be ready to move on to the next code challenge, which is a little bit more challenging. For all of that and more, I'll see you there. Hey guys, so I've got another code challenge for you. And this one, as the title suggests, this is a difficult challenge. And this is something that I expect some of you might need to spend 15-20 minutes on. Others might need to spend 30-40 minutes on. And it might just be something that you need to have a think about, get stuck, come back to it after a bit of a break, or sleep on it, come back to it the next day. It's not easy, but what I'm trying to say is really, really give it all you have before you check the solution video, because it's a really, really interesting challenge. So the idea is that we want you to write a program that works out whether if any given year is a leap year. We know that a normal year has 365 days, but leap years have an extra day in February. And the reason is actually really, really interesting. If you're interested, there's a really good explanation of how leap years work and why we have them at this YouTube link. So just go ahead and copy this URL and check it out. Now, the way that you work out if a given year is a leap year, so let's say we pick one out of thin air, 2020, is that on every year that is evenly divisible by 4, so that means divisible by 4 with no remainder, then that is a leap year. But except the years that is also evenly divisible by 100, unless the year is also evenly divisible by 400. Now, 2020 divided by 4 is equal to 505. So it's evenly divisible by 4. There's no remainder. But the rule says that even if it's divisible by 4, if it's evenly divisible by 100, then that is still not going to be a leap year. So let's try that. 2020 divided by 100 equals 20.2. So this is in fact not evenly divisible by 100. So that means it is still a leap year. But then it says unless the year is also evenly divisible by 400. So 2020 divided by 400 is not evenly divisible. So it is in fact still a leap year. The trickiest part of this entire challenge, I would say, is getting your head around these 3 sentences. A year that is divisible by 4 with no remainder is a leap year, except if it's also divisible by 100. In that case, it's no longer a leap year, unless that year also happens to be evenly divisible by 400. Then it is still a leap year. What I recommend doing is A, if English is not your native language, then have a look online for the rules for determining a leap year in your own language, because these words, except and unless, are so integral to how this algorithm works. And you really, really need to understand exactly what it means. Then what I recommend you doing is to go ahead and create a flowchart, just like what I've done in previous examples. Head over to a website like draw.io, or simply just write it on a piece of paper. Draw it out and visualize what this actually means in terms of your code. Now, if you really get stuck on that, I've also created a flowchart for you. So if you actually get stuck creating the flowchart, there is one there that you can refer to as well. But it's a really good exercise creating your own flowchart based on what it is that you want your program to do. And your algorithm or your code should correctly tell us whether if it's a leap year or not a leap year. So it just has to print out leap year if it is like 2400, And if it's not a leap year, like 1989, then just print not leap year. This is the time to pause the video and really give this challenge everything you've got. I'll see you back here once you're done. All right, so how did you get on? As I mentioned, this is a really difficult challenge. If you haven't managed to solve it, then try to come back to it a little bit later on and spend more time on it. This is a decisive moment. Don't give up on yourself. Keep going. I'm always going to be here for you with the solution. You're not going to get stuck. It's really, really important to try and solve it yourself. Now, the first thing I mentioned is turning this rule for determining whether if a year is a leap year or not into a flowchart. So I've created one which I linked to in the challenge, and it's very simple. We start off by asking ourselves, is a particular year that we have in mind, let's say the year 2000, is it cleanly divisible by 4? Which means, can you divide it by 4 with 0 remainder? Well, if the case is no, then it's already definitely not a leap year. But if the case is yes, then we have to ask ourselves some more questions. Namely, can we divide it by 100 with no remainder? Well, if we can't, then it's definitely a leap year. But if we can, then we have to check yet again. Can we divide it by 400 with no remainder? If the answer is yes, then it's a leap year. If the answer is no, then it's not a leap year. Let's try and code that logic out. Keep your flowchart up somewhere so that you can write your code while referring to the diagram. We start off by checking whether if the year that came in through the input is divisible by 4 with no remainder. And you might remember from our previous code exercise that the way we do this is using the modulo. So year modulo 4 will give us the remainder. So if the remainder is equal to 0, well, in that case, it's cleanly divisible by 4. And you can check this out yourself in the console. Let's say if you have 8 modulo 4, 4 goes into 8 cleanly, there's 2 4s in an 8, the remainder is 0. Whereas 9 modulo 4, 4 plus 4 is 8, remainder 1. So if the remainder from the year divided by 4 is equal to 0, then it is cleanly divisible by 4. So in this case, we'll have to go into yet another if statement. But if it's actually false, then it's definitely not a leap year. So the else statement that matches this if statement is going to tell us for sure that this is not a leap year. But if it is true, then we have to check the next thing. Is it cleanly divisible by 100? So we check if the year modulo 100 is equal to 0. And if the answer is yes, then we have to check that year against another question. But if it's no, then it's definitely a leap year. In this case, that will lead to an if statement if it's true. But if it's false, then we can simply print leap year because that's what it's going to be. The final question that we have to ask ourselves about the year is it cleanly divisible by 400? So now if year modulo 400 is equal to 0, well, in this case, if it is true, then it's definitely a leap year. If it's false, then it's definitely not a leap year. So we can print leap year if it's true. Otherwise, or if it's false, then we can print not leap year. And that's it. That's all the code that you would need in order to represent this logic. Now, there's plenty of other ways that you could have written your code, but this is probably the most readable. Now, if you've written some different code, but it still uses these rules to work out whether if a given year is a leap year and it's correct, then that's fine as well. There's plenty of ways that you can solve this challenge. the most important thing I want you to take away from this code exercise is that you can turn any sort of logic into a flowchart to be able to visualize it. And once you've got your logic straight, then converting it into code is much, much simpler. If you haven't figured out the logic and then you try to start writing code, then it's going to be a mess. So first, get to the stage of being able to create your own flowcharts and then take those flowcharts and turn them into code. If you got stuck on this challenge, or if you didn't manage to complete it for some reason, head back to it now and give it some extra attention, because this is really, really important. It's in these moments, these code challenges, where you're actually going to level up as a programmer. It's not during the tutorials. It's not during the videos where I explain things to you. It's where you actually write the code yourself. I hope you had fun on this code challenge and you managed to complete it, be it with hints or without hints. On the next lesson, we're going to take the if statement one step further, and I want to show you how you can have multiple if statements and test for multiple conditions. So for all of that and more, I'll see you on the next lesson.